So we're continuing our concept of solving, but this time we're solving with what we call roots and powers. Well, roots is when we do like the square root, like the square root of 4, for example. Powers is when we have exponents. That's what we mean by powers. So the question is, how do we get rid of those things? So we have a rule that says when you square the square root of any positive number, the result is that positive number. And the second rule says when you take the square root of a number that is squared, the result is the absolute value of that number. So let's talk about what this means. So let's, for example, look at the square root of 4 squared, which is exactly what this first problem says. I've just put a number in there instead of a letter. Okay? Well, what happens is that they're telling us that what I should end up with is just the number 4 itself. But let's actually do the work. So if we think about this, the square root of 4 is whatever number times itself gives you 4. Well, the square root of 4 is 2. So if I take the inside part, I'm just left with 2, and I still have that exponent on the outside. 2 squared is 2 times 2, which is 4. So what happened is that I ended up with what I started with inside. So the rule here under variables says that the square root of d squared is d. So using that same concept, then the square root of 5 squared is just going to be 5. Now notice that this is different than the next one, because this here says you take the square root, then you square it. This says you square it and then take the square root. I know it seems like it should be the same thing, but it's not. But here's what happens. In this case, the answer is still d, but it's not just d anymore. It's what we call the absolute value of d. An absolute value is kind of like a washing machine. I know this sounds really weird, but I promise it'll make sense. If you put something dirty in the washing machine and you take it out, it's going to become clean. If you put something clean in the washing machine and you take it out, it's still going to be clean. So what happens with absolute value is when you put something in absolute value, what that means is it always turns out positive. That's like the clean version of the number. It always turns out positive. So if I had the absolute value of -4, it would be positive 4. If I had the absolute value of 5, it would be 5. If I had the absolute value of -0.2, it would be positive 0.2. Alright, so absolute value always comes out positive. So using that logic, then I have the square root of 5 squared is just going to be the absolute value of 5. So this question says, why does the absolute value of x equals 4 have two solutions? Well, the reason it has two solutions, remember that x is always comes out positive. It doesn't necessarily start out positive, but it always comes out positive. Well, if you put -4 in there, it's going to come out positive 4. If you put positive 4 in there, it's also going to come out positive 4. We're going to look at number 3. Why does the absolute value of x equal -2 have no solutions? That means why doesn't it work? Well, because absolute value always turns out positive. It can't ever turn out negative. And the reason this matters is because when we get to questions like number 4, which says, why does x squared equals 16 have two solutions? Well, in order to solve this, so we said that squaring and square rooting undo each other. So what you need to write this down, that taking the square root and squaring a number are opposites. So when we were adding and subtracting, to solve the problem, we had to do the opposite. The opposite of adding was subtracting. The opposite of subtracting was adding. When we were multiplying and dividing, we had to solve by doing the opposite. So the opposite of multiplying was dividing. The opposite of dividing was multiplying. Let's write that all down. So adding, to solve, we had to subtract. And for subtracting, we had to add. For multiplying, to solve, we had to do the opposite, which was to divide. So now if we have something that is square rooted, the opposite of that is to square it. Or if we have something that is squared, the opposite of that is to square root it. So looking back at problem 4 that we had up here, it says x squared equals 16. So if I have x squared equals 16, to solve this, I have to do the opposite of squaring it, which is to take the square root of both sides. And we learned that squaring and square rooting, they're going to cancel each other out, so we're just left with x. And then we take the square root of 16. Well, what number, when we take the square root, we're trying to figure out what number times itself gives us 16. Well, 4 times 4 gives us 16, and negative 4 times negative 4 also gives us 16. That's why we have 2 solutions here. So we've got some steps that they give us. So to solve an inequality, so now we're solving inequalities, in the form of square root of x is greater than b or square root of x is less than b, we're going to do the following. We're going to square both sides, because squaring both sides gets rid of the square root, because remember squaring and square rooting are opposites. Then we're going to simplify and write the solution set as an inequality. This part here you need to highlight or underline or something, put big stars around it, doesn't matter, because this is going to help you tremendously, because it's going to tell you what your answer should look like. If your problem says the square root of x is greater than b, your answer is going to be x is greater than b squared. Every time it will go from this to this. If it says square root of x is less than b, then your answer is going to look like this. And this weird notation, I understand that, but think about this. If I ask you to describe where x was, you would tell me, physically tell me where x is in this little part right here that I've underlined. You tell me x is in the middle of 0 and b. Well, that's exactly what this means. This means that x, our answer, has to be between 0 and b squared. And this is because x can't be negative. That's why we have that little bottom number there. So looking at number 1, it says square root of x is greater than 2. Well, if I look back up here, this is my first problem. Square root of x is greater than 2. So it tells me the solution should be x is greater than whatever this number was over here squared. So 2 squared. Well, what is 2 squared? The answer to that is it's 4. And now we have to graph this. So recall, we've already talked about how to graph these. Because it's just greater than, we're going to put an open circle at 4. And it wants x's that are greater, and things that are greater are to the right. So that would be our graphical answer. For the second one, it says the square root of x is less than 2. Well, that, thankfully, looks just like our second problem we had here. And it told us our answer should look like this. 0 is less than or equal to x, which is less than, and it says it should be b squared. Well, that would be 2 squared in this case. And 2 squared is really 4. So this time, this is going to have 2 dots, because I've got 2 numbers on here. At 0, there's a less than or equal to, which means there's going to be a solid dot. At 4, there's just a less than, so there's going to be an open dot. And when I have this, it's really easy. Because when x is here in the middle, I just connect the two dots. All right, if you will move on to the next page and look at the top. So they've showed us how to work these problems out, but this is really what I want you to pay attention to. Okay, to solve these, x squared is less than 25. It tells us we have to take the square root of both sides. Well, that makes sense, because the opposite of squaring something is square rooting it. And the square root of 25 is 5. But they have these weird things, absolute value of 5. Here's what you need to know. If the symbol is a less than, you have a problem like this, x squared less than a number. If the symbol is a less than, then your answer will be like this. You go ahead and you take the square root of 25. So I'm going to rewrite this. The square root of 25 is 5 and negative 5. Remember, there's always 2. Always 2. You always write the negative one first. You always write the positive one second. Doesn't matter. Always. And this is your answer. If your problem, if it's a less than symbol, your answer will look like this. Just like that. And your graph, because they're going to ask you to graph these as well, will have a number line. It'll have those same two numbers marked off. It'll have open or closed circles depending on if it's just less than or equal to. And the dots will be connected. Okay, so less than, it's going to have this kind of answer, and it's going to have this kind of graph. This is really a matching game. That's all you have to do is be able to do a matching thing. So less than, it's going to have this answer, this format. Negative 5 is less than x, which is less than 5. And this kind of graph where the line's drawn in between. The opposite's going to be true if it's greater than. So if it's greater than, which is what this one is down here, then your answer is going to have or in the middle. So greater than is going to have or, and your graph is going to look like this. It's going to have two dots, but the arrows are going to be going opposite directions, okay? So it's really all you have to remember is that the greater than looks like this is an answer choice and this is a graph. The less than looks like this is an answer choice and this is a graph. I'm telling you, if you can match those things, you'll be good to go. So moving on to the checkup. Number 1, we actually have to solve these. If they're equal to, you need to solve, you need to get an answer. So if it's just equal to, you want an answer. And that answer needs to be an actual number. So if you have the square root, to get rid of that, you're going to square both sides. And the square and the square root always cancel each other out, and we're left with x equals 11 times 11 is 121. Number 3, we have x squared equals 25. So to get rid of that, I'm going to take the square root of both sides. The square root and the square cancel, and I'm left with x equals. The square root of 5 is 5 and negative 5. You might want to make a note here. When you take the square root, there is a positive and a negative answer. So there's going to be two answers. Okay? When you take the square root, you're going to get a positive and a negative answer. When you're squaring it, though, here, like problem 1, you only get one answer. Okay, so for 5 and 6, we're supposed to determine whether the number is in the solution set or not. So for number 5, I'm supposed to determine whether x equals 4 is a part of the solution. Well, I can do a whole bunch of work and I can solve this, but if it wants to know if 4 is a solution, then I can just set x equal to 4. So I can rewrite this as the square root of 4 is less than 14. Well, the square root of 4 is 2. And the question is 2 less than 14? Well, that is true. So yes, x equals 4 is a solution. So looking at number 6, just to give you some more practice with this, we can again plug it in. Whenever it wants to know if something's a solution, you can always just plug the answer choices in. It's really a good option. So I have a square root. It tells me x equals 36 is greater than or equal to 7. Well, the square root of 36 is positive 6. And the question is that greater than or equal to positive 7? Well, 6 is not greater than 7, or it's not equal to 7. 6 is less than 7. That's not true. So no, x equals 36 is not a solution. Let's look at number 7. We have x squared is greater than 49. We're supposed to write the solution set to the inequality. So that I'm going to square root both sides. So I get x, and the square root of 49 is positive 7 and negative 7. Okay, this is one of those where you're going to want to go back and look at your notes. So I've inserted my picture of the notes that I'm talking about here. And we just have to look at our sign. Well, this sign is a greater than sign. So that tells me I'm going to have an or in my answer. So it says that x is less than, and then it had the negative number there, so negative 7. And then it said x is greater than, and this one side was the positive number, so positive 7. So that would be my solution set. X is less than negative 7, or x is greater than positive 7. So number 9 wants the same thing, but this time we're supposed to draw it out. Well, we've got to look at our sign. The sign is a greater than or equal to, so that means I'm looking at this second set here because it's the same sign, greater than or equal to. So it tells me I'm going to have a number line, and my number line is going to have 2 dots, and notice they're going opposite directions. So just figure out what my number is. To do that, all I got to do is take the square root of 4. Square root of 4 is 2 and negative 2. So that's my 2 numbers that go on my number line. In this case, because it is greater than or equal to, my dots are going to be solid. And I'm going to draw arrows going opposite directions.